Hello everyone, am I audible?
Yes, sir. Good evening.
Good evening, Krishna. Kulsum, Ronaldo, everything good?
Yes, sir.
All right. Any doubts from the last class?
No, sir.
All right. And you haven't submitted your assignments, right, Ronaldo?
Yes, I haven't submitted because there are exams from next week, so I'm preparing for it. But my
Kulsum,
assignments are almost completed, so I'll submit them.
All right. So please submit whatever you have completed, all right?
Yes, sir, sure.
And Kulsum, what about you?
I'll submit them today after class, sir.
All right. Krishna, I was checking your assignment. Get it. Here. All right. In this assignment, you have done everything right, but few lines are missing. All right. Because I told you in this questions, you need to worry about the writing pattern of your answer. All right, Krishna. So here you wrote 3,1 doesn't belongs to R. So R is not symmetric. You could just add one line to it that 1,3 belongs to R, but 3,1 doesn't belong to R. All right. So this
Okay,
would be
sir.
perfect. And in this question also, right? The same mistake.
Yes, sir.
All right. In this question, you reverse the relation, right? They've told you R is all the ordered is A comma B such that B is divisible by A. But here you wrote X comma Y, X is divisible by Y. So you reverse the relation. So this would be wrong. All right.
Yes, sir.
So even though your method is right, just a silly mistake. And yes, and here also you missed one line. You could write that adding equation 1 and 2, we can get that x minus z is also an integer, right?
Yes, sir.
You wrote here. So that would be perfect answer. Yeah, everything else was all right. All right. So these are the few mistakes you could develop in the next assignment. All right, Krishna.
Okay, sir. Yes, sir.
All right, then let's start with the question. No doubts from the last class, right? Anyone?
No, sir.
Anything? All right. Let's move on then. Next question. These till now we are solving the symmetric, reflexive, and so on, right? Does anyone remember what is an equivalence relation?
So when all three are true, then it is called equivalence relation.
Absolutely right. So if they are going to ask you about equivalence relation, in most of the cases they are going to tell you that this relation is an equivalence relation. All right. And then they will ask few questions about that, or they will ask you show that this is an equivalence relation. So one thing we know that whenever you get the question like that, that is an equivalence relation, right? If they ask you to show that this is the equivalence relation, this means that that is already an equivalence relation. This you know, that means that is reflexive, symmetric, and transitive. So you just have to figure out how to write the answer, right, everyone?
Yes, sir.
So let's focus on that now. Questions. Based on equivalence relation. What is the first question? The first question says, let R be a relation on the set of all lines in a plane defined by L1, L2 belong to R. Line L1 is parallel to line. Show that R is an equivalence relation. Alright, this is the question. This symbol here means if and only if. I hope you know this, right? This symbol means if and only if. Line L1 is parallel to line L2. Alright. This question is clear to everyone?
Yes, sir.
Alright, Ronaldo Kulsum?
Yes, sir.
Yes, sir.
Alright. So in this question, they are asking you to show that this relation is an equivalence relation. So we already know that this relation is reflexive, symmetric, and transitive. Now we just have to think how to write. So do you want to try this, or shall I show how to write? Everyone? Krishna, Ronaldo, Kulsum, do you want to solve this first?
Can you solve the first one before I solve the other?
All right. Shikani has also joined. Good evening, Shikani. Shikani, are you there?
Yes, sir.
Everything good?
Yes, sir.
Why haven't you sent any assignments?
Sir, the same problem, sir. I didn't get it.
Did you check the portal?
Sir, the portal is not an option for me because it does not open. So there's some red text when I click on assignments.
Let's move on then. Shikani, we have started this question. Let R be a relation on this right set of all the lines in a given plane defined by L1, L2 belongs to this relation R if and only if line L1 is parallel to L2. Or let's show that R is an equivalence relation.
Sir, what does equivalence relation mean? I forgot.
Forgot. All right. So equivalence relation is where the relation is all three. All three means reflexive.
Okay, yes, understood. Remembered, yeah.
So in this type of question, we already know that R is an equivalence relation. So we just have to think about how to present the answer. All right. So how to present? I'm going to solve the first one, then I'll give you questions to solve. So first is reflexive. Shikani, what is reflexive relation?
Reflexive is 1 1.
1 1. Reflexive is 1 1. This is how you should define a reflexive relation.
If 1 comma 1 is part of R, then it's reflexive.
But there is no 1 1 here in this question. So how can you say 1 1?
I don't know, so I have to solve this.
All right, Ronaldo, how can we define reflexive relation? Ronaldo, you there? Now, Kulsum,
Sorry, sir.
how can you define reflexive relation? What is a reflexive relation? All right, Kulsum, can you answer this?
In reflexive relation, like for an example 1, it should have 1 comma 1, or for 2, it should have 1 comma 2 as its elements.
Right. So in this question, what should happen if this relation is to be reflexive? What should happen in this question?
Then L1 and L2 should be parallel with itself.
Right. So see, we are not just talking about L1 and L2. What are they saying? They are saying this relation is on set of all the lines on a plane, right? So let me explain you guys again. What is reflexive relation? Each element, you can read the definition where in the previous classes, each element should be related to itself. All right. Is this clear? Each element. That means whatever the set is defined on, whatever. So here the set is all the lines in a plane. How many lines are there in this plane? In a single plane, how many lines are there?
So infinite.
Infinite. So we have to prove for infinite lines that each line will be related to itself by this relation. And what is the relation? That one line should be parallel to another line. Is this clear now?
Yes, sir.
So what can we expect from this question? We have to prove that L1, L1 belongs to R, right? Or L2, L2 should belong to R. This is clear?
Yes.
Kulsum, Shekani, Ronaldo, this is clear?
Yes.
So we have to prove for each element. So how we can prove for each element? Let us assume that, let's say L1 belongs to set of all line in a plane. Right? Let L1 be a line on that. So we know that L1 is parallel to itself. Right? Each line is parallel to itself. So we can say that L1, L1 belongs to R. So R is reflexive. Is this clear?
Yes, sir.
Everyone, this is clear?
Yes, sir.
Yes.
So this is the way to write. What is next one? Symmetric. So what is symmetric relation?
So L1 comma L2 and L2 comma L1 belong to the set of, I mean, the, yes, sir, set.
Alright. So if there is no L1, L2, then what happens?
I didn't get it, sir.
Identity. So what happens in that case? Suppose I give you a relation R 1, 1, and if I ask you this is symmetric or not, what would you answer?
Yes, sir, it would be symmetric because
Because
so 1 comma 1 is itself symmetric. That's why like 1 comma 1 and its mirror image is also 1 comma 1. So
right, absolutely right. Kulsum, this is clear. What is symmetric?
Yes, sir.
All right. So how to think about symmetric? Always assume one element, right? In symmetric, the symmetric relation says if L1, L2 belongs to R. This is a given thing. All right. This is a given thing in symmetric relation. Always assume this. This is the first step to prove anything is symmetric. Always assume that L1, L2 belongs to R. This means L1 is parallel to L2, right?
yes, sir.
Because the relation says that the relation is given by this condition. L1 is parallel to L2. And if we have assumed that L1, L2 belongs to R, that means L1 is parallel to L2. Now for this to prove that this is symmetric, we have to prove that L2, L1 also belongs to R. right?
Yes, sir.
Everyone, right? So by this, we have to prove that L2 is parallel to L1. This should be our end goal, that this is the assumed condition and this is the end result we have to reach. So how we can reach that? We have assumed that if L1, L2 belongs to R, this implies that L1 is parallel to L2. This implies that L2 is parallel to L1 also, right? If one line is parallel to other, that means the other is parallel to the first one also. So this implies L2, L1 also belongs to R, right? So R is a symmetric relation. Is this clear, everyone?
Yes, sir.
All right, Shikani,
Yes, sir.
this is clear, right? No doubts on this?
Yes. No, no.
All right. Now, what is transitive?
L1, L1, comma L2 is part of R.
Right?
Then wait, we don't have anything else.
Right. So see, in this question, they have told you that this is an equivalence relation. So we already know this must be transitive.
Yes, it is. So we have to just make up and say it's special case, I guess.
You don't have to think about special case. Just write this. In this case, also assume that let L1, L2 belongs to R and L2, L3 belongs to R. This should be your first step. All right. Everyone, this is clear.
Yes, sir.
Sir,
So
L3 is not there in the question, is it?
no. We assume that L1, L2, and L3 is 3 lines on that plane.
Oh, okay, okay.
All right, because the R relation R is on all the lines on a plane, right? Set of all the lines. So we can assume as many lines as we want.
Yes.
And what should be our end goal? That we have to prove that L1, L3 belongs to R, right?
Yes. Yes.
This implies that we have to prove that L1 is parallel to L3.
Yes.
So we have to reach to this point by solving this one. This will be your first step always.
Sir, L2 is parallel to L3 and L1 is parallel to L2. So L1 is parallel to
Absolutely,
L3.
absolutely right. So that line you have to write here, that L1 is parallel to L2 and L2 is parallel to L3.
L3. So L1
This
is parallel
implies
to L3.
absolutely right. So this implies L1, L3 belongs to R. So this is transitive. R is transitive. This is clear, everyone?
Yes, sir.
Wholesome, Ronaldo.
Yes, sir.
Yes, sir.
All right. So note it down. So this should be your first step always. In reflexive, always think about how you can reach to L1 is related to L1 or A is related to A. In symmetric, assume that A, B belongs to R. And you have to reach till B, A, right? In transitive, assume that A, B and B, C belongs to R. And you have to reach till A, C belongs to R. All right. Always think about this, that what we have to prove. All right. Note it down.
Done, sir.
All right. Next question. Show that the relation is congruent to on the set of all triangles in a plane is an equivalence relation. Right. Everyone have noted down this previous question?
Yes, sir.
All right. The second question is clear to understand?
No,
Everyone?
sir, not at all.
Not at all. All right.
Didn't
Let me
understand
rewrite this.
anything.
Let me rewrite this. This is the way they'll confuse you because they cannot do anything else. If I write this, let S be all S be set of all the triangles in a plane. And R is defined as A comma B such that A is congruent to B for all A comma B belongs to S. All right. Now, is it a little bit easier? They are saying any ordered pair A comma B where A is congruent to B, where A and B are both triangles, right? If they are congruent to each other, then this ordered pair will belongs to R. You have to prove that this relation is equivalence relation. Is it clear now, Shikani?
Yes, sir.
All right. Shikani, what about you?
Yes, sir.
All right. Kulsum, Ronaldo, this is clear. Question is clear.
Yes, sir.
All right. So I'll give you 3-4 minutes. Try to prove this.
Done, sir.
Everyone solve this?
Done, sir.
All right. Ronaldo, Shikani.
Yes, sir.
All right,
Sir, done.
Shikani, done. All right. Do you want me to solve this?
Yes, sir.
All right. So how to check reflexive? Reflexive means each triangle should be congruent to itself, right? Related to itself. And we know that that is true. So we can simply write that each triangle is congruent to itself. So R is a reflexive relation, right? We don't need to write anything else on this. What about symmetric? Also, how we can solve this symmetric thing?
A comma B is an element of S, and B comma A is also an element of S. If A comma B is congruent, then B comma A should also be congruent.
Right. So how we can write this more orderly? We can say let A comma B belongs to R, right? And Kulsum, you don't have to write this thing twice. A and B are two elements in S. That means B and A are two elements in S, right? The same thing here. You can write let A comma B belongs to R. This implies that A is congruent to B, and this implies B is congruent to A. So this would imply B comma A is also in R or belongs to R. So R is a transitive relation. Sorry, symmetric relation. All right, Shekani, this is clear.
Yes, sir. Symmetric is already reflexive.
And Krishna, how we can prove transitive?
So let A comma B belong to R and B comma C belong to R. This implies that A comma C also belongs to R, and
Right,
hence
but again, you missed one line here. All right, in fact, two lines. First, you have to mention that let A, B, and C belongs to S, right? A, B, and C are triangles. That you have to clarify. Now this line is perfect. After that, you can write this implies A is congruent to B and B is congruent to C. Right, Krishna? I also understand that directly we can write. That
so
is
the second
implied.
statement I have written in my notebook, but I didn't tell, sir.
All right, all right. Then it is okay. You always have to write this, right? See, the teacher also knows that this is congruent. I also know, everyone know. But we have to show them, right?
Yes, sir.
That we know this. So this implies A is congruent to C. This implies A comma C also belongs to R. So R is a transitive relation. All right. So this implies this is an equivalence relation. All right, Shekhani, now this is clear. Shekhani, this is clear now.
Yes, sir. That is clear.
All right. So let's try another question. Show that the relation R defined on the set A of all triangles in a plane as r equals to t1 comma t2 such that t1 is similar to t. Is an equivalence relation. Consider three right angle triangles T1 with sides 3, 4, 5, T2 with sides 11, 13, and T3 with sides 6, 8, and 10, which triangle among them are related. Alright, the question seems very long to read, but very easy question. Alright, almost similar question to the previous question. Right, everyone?
Yes, sir.
Shikhani, can you tell me what is similar triangle?
Sir, can you say again?
What is this? What is similar triangles?
Similar, they're same, but the ratio is different.
Right, or you can just say the ratio is same, right?
Yeah,
A1 by
ratio is
A2
same.
equals to,
Yeah,
right?
ratio is same, but its size is different.
Absolutely right. So this is clear. The question is clear, everyone. Krishna, Kulsum, Ronaldo,
Yes, sir.
questions.
Yes.
All
Sir,
right,
can you read the question once?
all right. Question says, give me a second. The question says, show that the relation R defined on the set of all triangles in a plane, right? All the triangles you have to assume in a plane, that is the set defined as T1 comma T2, where T1 is similar to T2, right? If you take two triangles, if they are similar, then they belong in R. This you have to prove as an equivalence relation. Consider three right angle triangles. This is the second part. All right, they are asking you to consider three right angle triangles, T1 with sides 3, 4, 5, and T2 with sides 5, 12, and 13, and T3 with sides 6, 8, and 10. Which of them are related? Related means by this relation. All right.
Okay, sir, got it.
In
So
the
what's
second
the
part,
last line, sir? Which triangle?
among T1, which triangle among T1, T2, and T3 are related. All right. Simply means which of them are the ordered pair which are in R. All right. Can you guys prove this or not?
Yes, sir.
All right, I'll give you a few minutes.
Done, sir.
All right. Everyone solve this?
Yes, sir.
Shikani, have you solved this?
No, sir, solving.
Solving it. All right. Ronaldo?
Yes, sir.
So this is also easy, same as the before question. What is the answer of the second part? Anyone?
So T1 and T3 are related.
T1 and T3 are related. Why is that?
So because the ratio of their sides are equal.
Absolutely right. Because 3 by 6 is equals to 4 by 8 is equals to 5 by 10. This is the condition from which we check similarity of triangle, right? Class 10.
Yes, sir.
Shikani, this is clear?
Yes, sir.
All right. So no need for me to solve this, right?
No, sir.
No.
No, sir.
All right then. Let's move on to another question. Let n be a positive integer. Prove that the relation R is set of integers defined by x comma y belong to R such that x minus y is divisible by n is an equivalence relation. On set. Write this question down. Done, everyone?
Yes.
So is the question clear? Shikani, the question is clear to understand?
Yes, sir.
So try to prove this. All right. And write this answer very carefully. All right. They are saying x minus y should be divisible by another integer n. Right. In the previous questions, we have solved that y is divisible by x. But here n can be any integer, any positive integer.
Done, sir.
All right. Everyone solve this? Shikani, Ronaldo, Kulsum.
It's just a moment. Done, sir.
All right. Rest of you, Kulsum, Shikani.
Done, sir.
All right, Shikani, do you want me to solve this?
No, sir, I don't know this one.
You know this one. Everyone, is this clear? Let me just solve this one. All right.
Yes, sir. Please solve.
Yeah. So how to prove reflexive? We can say that let x belongs to z, right? Because r is on z of integers. So let x belongs to z. So we know x minus x is equal to 0, which is divisible by n, right? 0 is divisible by any integer. So we can say x comma x belongs to r. So r is reflexive, right? This is very easy. Everyone, this is clear?
Yes, sir.
All right. So symmetric. The first step is clear. This you have to write always let a comma b belongs to z and a comma b belongs to r. Now if a and b, a comma b belongs to r, that means a minus b is divisible by n, right? Now can I write that a minus b is equals to n times p, where p belongs to any integer? Can I write this one? Everyone,
Yes.
can I write? All right, Kulsum, Ronaldo, this line is clear.
Yes, sir.
All right, Shikani. See, let me explain. If we say 16 is divisible by 8, so can I write 16 equals to 8 times 2, right? Divisible by 2 and 8. So I can write 8 times 2. Or if you say 15 is divisible by 5, so I can write 15 is equals to 5 times 3. So if any number is divisible by any other number, that means there is an integer with whom I can multiply that previous number and get the whole number. The same thing is done here. If a minus b is divisible by n, then I can write a minus b equals to n times p, where p is any integer. All right. Now I can say b minus a equals to minus np, right? Multiplying a negative sign both sides. So can I say that b minus a is also divisible by n, because minus p also belongs to z, right? If p belongs to z, then minus p also belongs to z. This is clear, everyone?
Yes, sir.
So p comma a also belongs to r. So r is a symmetric relation. All right. Now transitive. let A comma B comma C belongs to Z and A comma B belongs to R and B comma C also belongs to R. Right? This is the first step. Whenever trying to prove for transitive, this thing you have to always mention. Now in equivalence relation, all right. So this implies that A minus B is divisible by N and B minus C is also divisible by N. So I can write A minus B is equals to N times P and B minus C is equals to N times Q, right? Where P and Q belongs to Z. Now if I add both of this, let this be equation 1, this be equation 2. Adding 1 and 2, I get A minus B plus B minus C equals to NP minus NQ. So this implies A minus C is equals to N times P minus Q. So P minus Q will also belong to Z, right? Subtraction of two integers is also an integer. This is clear.
Yes, sir.
So we can say A minus C is also divisible by N. This implies A comma C also belongs to R. So R is a transitive relation. This is clear, everyone?
Yes, sir.
Yes.
This is the way to write already the answer. So if anyone needs to note it down, then you can do it. Otherwise, we can move on.
Sir,
Does anyone?
sir, I want to note down the transitive part, sir.
All right, all right. Note it down.
Done, sir.
All right. Next question. Show that the relation R from the set A equals to 1, 2, 3, 4, 5, 5. R equals to A comma B plus that A minus B is even. Is an equivalence relation. This is the first part of the question. Second part says, show that all the elements of 1, 3, and 5 are related to each other. And all the elements of 2, 4 are related to each other. But no element of 1, 3, 5 is related to any element 2, 2. All right. Again, this seems like a lengthy question, but the second part is very easy. All the hard work is for the first part, where you have to show that this is an equivalence relation. The question is clear, everyone?
So I didn't get the second part.
Forget about the second part first. All right, Krishna, just try to focus on the first part. All right. If you can prove the first part, then you can make sense of the second part. All right.
Okay.
Kulsum, Ronaldo, the question is clear.
Yes, sir.
Yes, sir.
All right, Shikani.
Yes, sir.
All right. So try to prove it. Have you guys solved this?
Sir, I have solved the first part, sir.
First part, all right. Let me solve this.
Sir, can you solve the transitive one?
All right, all right. Let me start from the beginning. All right. How to solve the reflexive part. So if x belongs to A, then there is no mod, yes. Then mod of x minus x is equal to 0, right? Which is even. So x comma x belongs to R. R is reflexive. This is very easy, right? Reflexive part is very easy. Same with symmetric. Let A comma B belongs to A, right? And A comma B belongs to R. Then A must be equal to even, right? This implies that, see, in the modulus function, we can reverse the order and it doesn't matter, right? We can reverse the order and this will still be the same number. This is clear to everyone?
Yes, sir.
So this is also even. So this implies B comma A also belongs to R. So R is symmetric. Now comes the transitive part. How to prove the transitive thing. Let A, B, and C belong to A, and A comma B belongs to R, and B comma C belongs to R. This implies that A minus B is even, and B minus C is also even, right? Now we have to think about how this can be even. See, if the subtraction of two numbers are even, that means if A minus B is even, that means A and B are both odd or even. Is this clear to everyone?
Yes.
Right? The subtraction of two numbers can be even if and only if either both of them are odd or both of them are even, right? Kulsum, this is clear?
Yes, sir.
So this we have to write for this B and C also. If B minus C is even, that means B and C are both either both odd or even, right? Now we have to assume cases because we cannot solve for even and odd simultaneously. So let us take case 1. B is odd. All right. If B is odd, this implies that, or we can write the first time here, A minus B is even and B minus C is even. This implies that A and C both are odd, right? If B is odd, that means A and C both should be odd. This step is clear, everyone?
Yes, sir.
So this implies that A minus C should be even, right? Subtraction of two odd numbers is always even. This is clear?
Yes, sir.
So A comma C belongs to R. But this is not complete now. We have to solve for case 2 also. And B is even, and A minus B is even, and B minus C is also even. This implies that A and B, A and C both are even. This implies that A minus C is even, right? Subtraction of two even numbers is always even. So this implies that A comma C belongs to R. So R is transitive. Is this thing clear or not, everyone?
Yes, sir. So I have a doubt, sir. Can't we do the other way, like mod A minus B is equal to P and mod B minus C is equal to Q, and then we add them?
Right, absolutely right. Let's try that one. All right, Krishna. I was hoping somebody would ask that question, and very good for asking that one. So we can write A minus B is equals to 2m, and B minus C is 2m, right? Now we can simply add this. A minus B plus B minus C is equals to 2 times m minus n, right? Now, Krishna, what do we want in the end result? We want A minus C mod.
Yes, sir.
Now, can you tell me if we can add this modulus function without opening the modulus?
No, sir.
No, right? So you know where we face the issue.
Yes.
Right? We cannot open both this modulus function without making 3 cases, right? Or 2 cases where this is positive. We need to make 3 cases where this is positive, this is negative, this is negative, this is positive, both are positive, and so on. All right. Remember how to open the modulus function? I hope you remember, guys. If A minus B, you have to open, you have to write A minus B is greater than 0 or A minus B is less than 0, right? And you have to open the modulus function accordingly. This is clear, everyone?
So can't we do like this, like modulus A minus B plus B minus C?
Like you want to open this directly?
Yes, sir.
No, you cannot open this directly. You can open on this line. This line you can open. You can write that A minus B modulus is 2m. This implies that A minus B is equals to plus minus 2m. This you can do. Right? You cannot open on this equation, but you can open these brackets, then you can add. All right, and so on for this. B minus C is equals to plus minus 2n. Now you can add, adding both equation 1 and 2. So A minus B plus B minus C is equals to plus minus 2m plus minus 2n. So this is A minus C is equals to plus minus 2 taking common. So this is m minus plus n. So you can make error on this, but that is okay. You cannot, just don't take plus minus common. So plus minus m plus minus n. So this is even. All right. Now removing the plus minus, you can take mod on both sides, and that would be okay. All right, Krishna. This you can do.
Okay, sir.
All right, but you have to open this modulus first. Don't try to open this modulus here. That would be wrong.
Okay, sir.
Also, this is clear.
Yes, sir, it's clear.
All right. Note it down, the transitive part. You can do this method also and the previous method also, whatever you feel is easier for you. All right, Krishna, now you can see the second part, right? Why that is being asked.
So there is no identity like modulus of A minus B plus modulus of B minus C is equal to whole modulus of A minus B plus B minus C.
Sorry, there is no identity like what you are saying.
So like the equation above, which is equal to like the whole modulus of A minus B plus B minus C.
Right. That is not the case. A minus B mod plus B minus C mod is not equals to mod of A minus B plus B minus C. This is really true. Or you have to make cases in modulus. Remember this always. In the next coming chapters, we have to prove this also. Whenever you have to deal with modulus function, try to open the modulus in the first or second line, right? whenever you see a function like this, x minus 2 modulus is equals to 5, just open this at that time only. X minus 2 is equals to plus minus 5. Do this. Never try to open this modulus in an equation. All right. In that case, that would be there. Like there is a high probability that you will do that wrong. If you remember, you have solved this type of questions in class 11th, maybe, that x minus a modulus plus x minus b modulus is equals to 5. So you assume three cases where x is greater than a, x is between a and b, and x is greater than b, right? So you take one here negative, then this is negative, then both are negative, and so on. All right, Krishna?
Yes, sir.
So never try to open this modulus in an equation where 2 or 3 modulus functions are there. Always open like this in a single function. All right.
Okay, sir.
I hope this is clear, Krishna. Your doubt is clear.
Yes, sir. It's clear.
All right, Kulsum, this is clear.
Yes, sir. It's clear.
And Ronaldo, Shikani.
Yes, sir. Yeah.
Right, I think this is a bit difficult question to understand, but it's okay. Now look at the second part. What they are saying in the second part. All right, in the second part, they are saying they have given you two sets. One set is 1, 3, 5. The other is 2, 4. They are saying all the elements of this set are related to each other. Right? You have to show this. So this is very easy. See, in this set, each of this element is odd number. Right? So if you take any ordered pair of these elements, then the subtraction of that element will be even. So that will be related in R. The same is the case with 2, 4. Both of the elements are even. So if you take the ordered pair, that means that would also be even. But they are saying no elements of this set and this set are related, right? If you take A from set this 1 and B from this set 2, they are not related. Why so? Because this is a set of odd numbers, this is a set of even numbers. So subtraction between an odd and even number is always odd. So this cannot be in R. Is this clear, Krishna?
No, sir. I didn't get it.
All right, let me explain again. They have given you, let me name this set B, 1, 3, and 5, and C, 2, 4. They are saying show that all of the elements are related to each other in this set B. All right, suppose in the given question, they have given you this set B, 1, 3, 5. So if you take any ordered pairs of this, from this set B, any ordered, so let A, B belong to B, right? For all A, B belongs to B. So can I say that A minus B will always be even? Can I say this or not, Krishna?
Yes, sir.
Right? Why so? Because all of them are odd. Right?
Yes, sir.
You can write this line. Because all elements of B are odd. Same thing I can say for A, B belongs to C. So mod of A minus B is even. Why? Because all elements of C are even, right? So no matter what, you can take any element from C and they will be in the set R, right? They will satisfy this condition. But they are saying if you combine these two sets, that means if, give me a second, one note is hanging. All right. If A belongs to B and B belongs to C, right? A belongs to B and B belongs to C. There is no ordered pair where A minus B is even. right? A minus B is not even A, right, Krishna?
Yes, sir.
Because A is odd and B is even. So no matter what element you choose, this will never be even. So A comma B does not belong to R. This is what they have asked you to show. Is it clear now?
Yes, sir.
So this way you can write that this is A is odd and B is even. So A minus B modulus is not even. So A comma B does not belong to R. All right. Kulsum, Ronaldo, Shikhani, this is clear.
Yes, sir.
All right.
Yes.
You guys want to note it down?
Yes, sir.
So let me go back to where surfing this OneNote is very difficult. Or my laptop is old, I guess. Or I am old, I guess. All right, see. This is the transitive part. All right, reflexive and symmetric you can write on your own. Transitive is this one. Please note it down. Tell me when you are done.
Yeah, sir. For this month's exam, we have matrices, determinants, and continuity.
Continuity, not trigonometric functions, inverse trigonometry.
No, not inverse trigonometry, and differentiability is also not there.
All right, then I'll talk to the team and we'll see if we can start with continuity first. All right.
Okay, sir.
But according to our syllabus, we want to go through inverse trigonometric first. But we'll see. All right, Kuch? Don't worry. But determinant and matrices is complete, right? Any doubts on that chapter?
No, no doubts. So,
No doubts, right?
continuity and differentiability, we'll start that for, because only differentiability is there and not continuity. And the first exercise is not there.
All right. All right. I'll talk to the team too. All right. Don't worry. We can try to start the chapter first. No worries.
Okay, sir. Thank you.
Anyone else has any exams?
Yes, sir. On Sunday.
This coming Sunday?
Yes, day after tomorrow.
Which
No,
which chapter is coming?
Continuity, differentiability, and there's some sixth chapter, I guess.
Sixth chapter they are asking. All right. So
Yeah, till sixth chapter. All of
I
them.
can only wish you the best. All right, Shekhani. That do well.
So that's why I was asking you to teach continuity and differentiability some days ago.
Right, right. But see, that is also a very long chapter, right? So we cannot see without there is an order, right? We cannot move to any random chapter without knowing the basics first, right?
Yes,
So
yes.
we'll try to learn about relation and functions first. Then we can start continuity. That is okay. All right.
So I am also having unit test from 19th of July, June, sir.
Which
And
chapters are coming?
so same, so matrices, determinants, and relations and functions.
All right. So your syllabus is completed, right? We'll take
Yes, sir.
another 1 or 2 classes to complete this chapter. Don't worry. So you are fine, I think. And Ronaldo, you don't have any exams?
So I also have like it will be starting from 19th, and maths exam is on the next week Sunday.
And chapters?
So, matrices and determinants.
So you are also okay then. So I hope you will get full marks, two of you, Krishna and Hamza. Also, at least I hope you get 80% at least, right? Because continuity is a
I'll
little
try.
less part. Yes, and Shekhani, I can only wish you the best. All right. We have no control over your exam,
Yes, sir.
right? Like they are moving in lightning fast speed, I think, in Shekhani school,
Yes, sir. Faster than that.
faster than that. All right. So that is why all I can see is a black hole in front of you. Right.
Yes, sir.
This is a physics joke. I hope you guys understand this,
Yes.
right? All right. Have you noted this down, everyone?
Yes, sir. Finished.
All right. Krishna,
Just a second,
Kulsum.
sir.
All right.
Done, sir.
So all the syllabus of other subjects are completed. Like, am I the only one who is lagging, or this is the same in every class?
No, no, same in every class.
Same in all right then. Then I'm safe.
Yes, sir.
All right. Krishna, done?
Done, sir.
All right. Let's solve another question.
Sir, can you show from that case too?
Case 2. All right. Case 2 is similar. You just have to write for even. All right, Krishna.
Sir, that's it.
What is that? It? Are you asking the class is over or not?
Yes, sir.
No, 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 no. We are going to solve another question.
Oh, okay. Okay.
All right, it's not the time yet.
Okay.
Do you have to go anywhere, Shirani?
No, sir. Yeah, you said done, sir. I thought it was over.
No, no. I'm asking Krishna if he is done with this question. All right, Krishna, done now.
Yes, sir.
All right. Write down. Show that the relation R on the set A equals to x belongs to z. 0 is less than equals to x is less than equals to 12. Given by the relation R equals to A comma B such that A minus B modulus is a multiple of 4 is an equivalence relation. Find the set of all elements related to 1, that is equivalence class 1. All right, here new thing is introduced which is called equivalence class. What is that? I'll explain after you solve this question. All right, don't worry about that now, just solve the first part. This is a similar question where we have proved that A minus B is divisible by n, right?
Yes, sir.
You can solve the same way by taking 4p or 4p like that, because that is a multiple of 4. All right, everyone is clear about this question? No one is clear?
Clear,
Yes,
sir.
sir. Clear.
All right, then solve it.
So what is after find the set of all elements related to?
related to one. All right, related to one, that is equivalence class, and this is square brackets 1. All right.
So can you explain the part for transitive?
All right. Everyone is clear about reflexive and symmetric?
Yes, sir.
Yes, sir.
All right. Shikani? All right. Let's see how to prove transitive. Let A, B, and C belongs to A, right? We take three elements from A, and A comma B belongs to R, and B comma C also belongs to R. This implies that A minus B, modulus of A minus B is a multiple of 4, and modulus of B minus C is a multiple of 4. Same way we can write that A minus B modulus is equal to 4m, right? And B minus C modulus is equal to 4n, where m and n some integer are some integer. Is this clear, everyone?
Yes, sir.
Now, Krishna, we can do your method, what you told in the previous question. We can remove the modulus function, right? So we can write A minus B is equals to plus minus 4m, and B minus C is equals to plus minus 4n, right? Opening the modulus function. Now adding, let this equation 1, this equation 2, adding equation 1 and 2. Give me a second. So this will be A minus B plus B minus C is equals to plus minus 4m plus minus 4n. So A minus C will be taking 4 common, plus minus m plus minus n. So we can say mod of A minus C is a multiple of 4. So this is transitive, right? This implies A comma C also belongs to R. This is clear?
Sir, if we do the before method, is it wrong?
Which method?
Sir, the method we used for the before previous question.
Right, but then how do you say that this is a multiple of 4? How do you solve this, Krishna, in that method? Can you tell me how you solve this?
No, sir, I am just asking, sir. I also don't know.
All right, so see, in that question we had to check about even and odd, right? So even and odd is very easy to distinguish, right? We can make two cases where both are odd and both are even, so we can choose that method. But in here it is a multiple of 4, right? So there is no other case how we can categorize this, right? We cannot write that A and B are such numbers that both are odd or even, because that is not always true. If B is 12 and A is 10, both are even, then but A minus B is not a multiple of 4, right, Krishna?
Yes, sir.
So this method is the perfect method to show how this is a multiple of 4. All right,
Yes, sir.
this is clear to everyone. Ronaldo, Kulsum, Shikani.
Yes, sir.
All right, you can
Yes.
note it down. Note it down, please. Done, everyone?
Done, sir.
All right. Now the second part says equivalence class of 1, right? The question says equivalence class of 1. So what is equivalence class? Equivalence class of 1 is the set of all elements from set A who are related to 1. This is as simple as this. If they ask you any equivalence class, first case is where first necessary thing is that must be an equivalence relation, right? If the relation is an equivalence relation, then for each element we can figure out equivalence class. And what is equivalence class? All the elements A comma 1, all right, which belong to R. All right, you have to write all the A's. Is this clear? All the elements were related to 1, all the ordered pairs where 1 is the one element. Is this clear, everyone?
Yes, sir.
So in this case, the condition was A minus B should be a multiple of 4. And can anyone tell me what was set A? What was set A? 1, 2, 3, 4, 5. Does it contain 6 or not? Let me check. Oh, this is till 12. Right. So this is
So
till 12,
0 less than equal to x less than equal to 12.
right? So 1 to 12, right?
Yes.
Less than equals to they are saying. So we have to take 0 also. All right. Now we have to choose all the ordered pairs where 1 is one element. So can anyone tell me what will be the answer? Equivalence class 1.
So 1 comma 0.
No, not 0. See, if you have to write all the ordered pairs, how you can write 1 comma 1 is there, and 5 comma 1 is there, and 9 comma 1 is there, and that is all, right? 1 comma 1 is a multiple of 4, 5 comma 1, 5 minus 1 is a multiple of 4, and 9 comma 1, 9 minus 1 is a multiple of 4. This is clear, Krishna?
Yes, sir.
So you have to write all the first elements where the second element is 1. This is called equivalence class. As simple as that. All the elements who are related to 1. So equivalence class of 1 will be 1, 5, and 9. Is this clear, everyone? Kulsum, Ronaldo, Fani?
Yes, that's clear.
All right. So can anyone tell me what will be equivalence class of 5?
So 1 comma 5.
So
Ronaldo, you were saying 1 comma 5, and is there any other element? One minus 5 is multiple of 4. 5 minus 5 is a multiple of 4. 9 minus 5 is also a multiple of 4, right? Is it clear, everyone?
Yes, sir.
So you have to check for all the elements. So this is clear, I guess. Any other number? 10? No. So this will be the answer. Kulsum, this is clear?
Yes, sir.
All right. Shikani? Shikani is not there. All right. So I forgot to take your Viva in today's class. So that will be in the next class. Please study accordingly of determinant and matrices. All right, everyone.
Yes, sir.
Any doubts from this class?
No, sir.
no, sir.
All right. Please keep revising. All right. Don't forget anything till the next class? All right, take care. This is all for today's class.
Thank you, sir.